Almighty Father in heaven, we thank you so much for the gift of today. Lord, thank you for the gift of life. Thank you for protecting us through the night and bringing us to this wonderful day. Dear Lord, we place each and everything that is going to happen today into your able hands. May you bless the works of our hands, O King of glory. Lord, we ask for your guidance throughout this lesson. May you come and intervene, O Father. May you bless our teacher and give him all the strength, Father. We also ask that you may bless all the minds that are here. Help them to capture each and everything. Cancel the spirit of dozing and feeling sleepy. We pray, O Lord Jesus, that may you take charge and take control. And we pray that at the end of the day, we shall learn something. We have prayed less but expecting more from you, and above all, Lord, may your will be done. In Jesus' name I've prayed and believed. Amen.
Thank you so much, Patricia, for the word of prayer. Good morning once again, dear friends. Thank you so much for sacrificing your time to be on the call. Today, we are going to look at what we call the inverse of a function. Last week, we introduced, on Monday, we talked about the inverse of a function, but we did not complete because when it comes to inverse of a function, we have two approaches. We have the graphical approach and also we have the algebraic approach. So today we are going to look at both, but our major emphasis is going to be on the algebraic approach. Okay, so my expectation that by the end of this lesson, each one of you should be able to find the inverse of a function, both algebraically and graphically. So we are going to start. We have a graph here and they're asking us to find the inverse of the function. I remember telling you that when we talk about an inverse of a function, it is more or less like reversing a process. Whenever you reverse a process, we can say mathematically that you are making or you are getting an inverse. Now, when you look at what we have, I told you that whenever they talk about an inverse, one of the things that will have to come to your mind, one, is that there is what we call a reflection. Remember, we said that when I walk like this and I go like this, when I come back, it means that I'm taking a reverse. Now, and we say that when we talk about the reverse, we are going to talk about what we call a reflection. And we say that an inverse is a reflection in the line y is equal to x. And we say that for a reflection in the y is equal to x, when we are making a reflection, it is a matter of just interchanging what has been your y becomes the x, and what has been your x becomes the y. Take an example. In case I have my point 2, 3, and I want to reflect it along the line y is equal to x, what we do, I just interchange. What has been my x becomes my y, and what has been my y becomes x, meaning that the reflection for this point is going to be 3, 3, 2. In case I have a point -2 and maybe +5, and I want to find its reflection, what I do, I'll interchange. What has been my x becomes my y, and what has been my y becomes my x. And therefore, my reflection now will be 5 and -2. Now, whenever you find a graph and you have been told to find its inverse, what do? You look at that graph and extract points or coordinates that you can read. I want you to look at our graph they have drawn. Can you put in the chart some of the coordinates you can directly read from the graph? Put them in the chart. Those points that you can see from your graph, the coordinates touching the graph. Gloria has said, okay. Hunt has said 1, 1. Members, when you look at 1, 1, is a coordinate here, is one of them. That is one we can read. Another one, look at your graph, and now we are reading. Yes, always look for those direct ones. Someone has said 4, 2, but I think 2, 4, very good. And members have seen another coordinate as 2, 4. But we say that when we are doing this, so what do? Allow me to call this point A and allow me to call this point B. Members, our point A you have said is 1, 1. Can you put in the chat what is going to be the inverse of 1, 1? What is going to be the inverse of 1, 1? Put it in the chat. I want to see. Aha, Daniela M has said 1, 1. Hunt has also said 1. Joyce has said 1. Agaba 1, 1. Very good. And Trevor. Aha, now we have our B. Our B, you have said that it is 2 and 4. Members, what is the inverse of 2 and 4? What is the inverse? Aha, very good. It's going to become 4 and 2. Now, when we are finding for this number, what are we going to do? Those inverses you have obtained is what we are going to plot. So allow me to remove this, and now I plot my inverse. So when I come here, the first thing I can do, I can first draw my reflection line. We have said that our reflection line is y is equal to x. And in case you want, you can draw a simple table where you have x and y. We say that when x is 1, y will be 1. When x is 2, y will be 2. When x is 3, y will be 3. So when you look at my graph, you notice that that line will look like this: 0, 0, 1, 1, 2, 2, 3, 3. So that is our reflection line, and I can draw it in this format. I'm just drawing it to show you how it will look like. So that is our reflection line, and I can call this that this is my line, y is equal to x, and then you can indicate that this is your reflection line. Now, to obtain our inverse, we are going to use these two coordinates you have listed below already that we can easily read off from our graph. And allow me to use, let me use green. So the first one, you have said the inverse of our A, which was 1, 1, is 1, 1. So it remains here. Then the next one is 4, 2. So I'll come and I plot 4, 2. Members, you will notice that 4, 2, allow me to, if I extend my graph somewhere here, this is going to be my 4, and 2 is going to be here. That is my 4, 2. Then, members, what if another one I can use is 0, 0? So members, allow me to say that even 0, 0 is here. Now, what do you do? When you look at our graph that was given, it is a bit curving. So also we are going to curve. So I'll come here and I do like this, something like that. So, and I'll say that is my inverse for my function. So this is the inverse of our function f, which you can write as this. Members, let me know through the chat whether that is okay. Is that fine to everyone, how we obtain the inverse? Okay, people saying it is very okay, very good. So you can take some note, or you can draw it in your book and show that this is how you obtain the inverse. What is important, and for you to be able to come up with a good one, if you can read as many points, you read them. You can read as many points as you can. The moment you read them, then it will become easy for you to bring out the curve very well. So when you see it is curving, it will be curving. In case it is a line, it will be a line. Remember, reflection, what you put is what you get. So in case it is a curve, your reflection will be a curve. In case it is a line, your reflection will be a line. And when you actually look at this kind of function we have, you can notice that this function we have is a function that has an inverse, because when we use our horizontal line testing, you will notice that our horizontal line will only touch the curve at one point. But I want to let you know that this curve you are seeing here, this curve here, it came from this curve of this nature. It came from here, but it was just cut. Now, by cutting, it means that the domain was restricted. I want to let you know that for functions whereby you notice that this function here doesn't have an inverse because it is touching 2 points here. Are you seeing it is touching 2 points? So we shall say that it doesn't have an inverse. But you can make it have an inverse by restricting your domain or by cutting out a certain part. So now for this one, they had to cut out this part this side. And once you cut it out, it means that you remain with something like this, meaning that it can now have an inverse. So in case maybe you find a question asking you, does the function have an inverse? And then when you test using your horizontal line testing, and it actually doesn't have, but then they may ask you, is there a way you can make it have an inverse? Then you can just say yes by restricting on its domain. So you look out for the part you can cut off such that you can be able to get the remaining part. Members, are you good to continue? Okay. Hunter said, yes, we can continue. Okay, very good. Okay, that's how it looked like. Now I have another one, members. I have another one. The first thing we do, I want you to identify the points we can have the inverse. So you put in the chart which points you are noticing from that curve. Just place them in the chart. Any points that we can look at the points that you can read off, and then we start with someone is saying 2, 1. Oh, sorry. 2, 1. 2, 1 is a point there. This is one of the points. 2, 1. Another point. People have noticed 1, 0. 1, 0 is here. Then someone said 4, 2. 4, 2 is here. So you first extract your points on the curve. Another one is negative. Negative 1, 0, 1. That one has not come out well. Then I don't know the members are seeing this point here. 0, negative 4. Very good. Now, after obtaining some of those points you can read off, then you go on and find the inverse. So we have said that the inverse of this point is just a matter of you interchanging. What has been your x becomes your y. What has been your y becomes x. So the inverse will become 1, 2. When it comes here, you interchange, you get 0, 1. When it comes here, interchange becomes 2, 4. When it comes here, interchange becomes negative 4 and 0. Now, these are your values. So these are the inverse values that you are going to plot. So I'll come and I plot them such that I can be able to get my line. So I'll farm, but the first thing you do, you can first draw your line, your reflection line. And we said our reflection line is always y is equal to x. And y equals to x, it means that the y value is the same as the x value. So in case you want a table, you say x and y. So in case your x 1, your y is 1. In case this is 2, this is 2. In case this is 3, this will be 3. But always what I want you to remember is that that one is always the diagonal line that will go through 0. So my 1, 1 is here. My 2, 2 is here. My 3, 3 is here. My 4, 4 is here. Negative 1, negative 2, negative 3, like that. So it will be a line of that nature that we shall have as our reflection line. So what I do, I'll just connect like that, and then I'll say that this is my reflection line, which is y is equal to x. Now, the next task is you now plotting these points you have obtained. So I'll come and now I start doing the plotting. So the first one was 1, 2. 1, 2 is a point here. Then the next one is 0, 1. 0, 1 is a point here. Then the next one was 2 and 4. 2 and 4 is a point here. Then we had negative 4, 0. Negative 4, 0 is here. So when you look at it, since this was a curve, also you must bring the curve very well. So it was curving. So allow me to curve a bit, and I swear the mine will also come out. Okay, mine has, okay, you can draw a better one. Draw a better one. Let me give it another try. Something like that. So now this is going to be now your inverse, which you can call F inverse of X. So in case there's a curve, you make it so I can even, I'm going to put these ones to show that that is my curve. Members, are we on the same page? Is that fine? Is that fine? Agab, I'm going to talk about it again. Okay. Okay. Members are saying, yes, it is very fine. So that's how you get an inverse. Whenever you're given a line, you are given a curve, that is how you obtain it. Okay, now Agaba is asking me to talk about how we restrict the domain. Earlier on, we talked about conditions for an inverse to exist. For an inverse to exist, we say that we always use an horizontal line testing. Allow me to use here. Take an example. You'll find that you have been given a graph of this nature. Let me say this is our graph. And they'll ask you that find that is that function having an inverse. So when you draw your horizontal line, you'll notice that your graph is cutting here and your graph is cutting here. And we say that whenever your horizontal line cuts at more than 2 points or at more or equal to 2 points, then it does not have an inverse. So we shall say that this function doesn't have an inverse. However, that function, this function here, members, is the same as y is equal to x squared. Let me say here is negative 2 to be minus 2. Now, but this function here, you can make it have an inverse by restricting the x values. The x values here. So by restricting means that when you restrict it, you want the line to cut at only 1 point. So when you are restricting, it means that for you can say, I'm going to ignore the whole of this side, which has the negative. So when you ignore, remember this is your negative 2 somewhere here. So when you ignore the other side, it becomes like that. It remains only half of it. So once it remains half of it, it means that now you have restricted the domain. So your domain here now, for this case, you can say it is starting from 0 and maybe up to 5, 0 to 5. Alternatively, in case you wanted to restrict this side of the negative, it will remain like that. So here, this is where your negative 4 is, and this is where maybe your 0 is. So you find that here you have restricted, you have removed this side, this right-hand side. So meaning that here when you draw a horizontal line, you'll find that it has only 1 point where it is cutting your curve. That's what you call the restriction. Restriction means that your domain is restricted, is not an open domain. Open domain means that it can go uncontrolled. That is what I'm saying. Hope that is fine. Maybe let me say that let me say, okay, maybe I'll give you another example. Have you finished to write, members? And I remove this and maybe I give an example on restricting the domain. Have you finished to draw what you have on the screen? Okay, people are saying, yeah. Okay, let me first erase them here, and then I draw something still on this screen. So when you look at my screen, I want to give you just an example. When you look at my screen, I can come, let me say this is my curve. Okay, something like that. Now, when you look at this curve is the curve we call y is equal to x squared. Now, when you look at it, you will notice that your domain means the x values. So this is where the curve starts from and maybe it ends. Allow me to set ends here, like here. What will happen that here your domain are the x values, these x values that your graph is running from. So you notice that your domain starts from -3 less than or equal to x less than or equal to 4. Now, this is what we call the domain. Domain means the set of all the x values that your graph or function takes on. Now, when you look at this graph and you want to test it, whether it has an inverse, you will see that what we do, we get our horizontal line, we draw. So when I draw like this, you are noticing it is cutting here and here. So I can, just that 1 point is enough to conclude that that function does not have an inverse. Now, what about when I want to obtain it? When I want to find that, to obtain, it means that I have to change my domain. So take an example. When I change my domain, I can say, for my domain, I'm going to remove a part. So which part can I remove? When I change my domain and I say my domain is going to start from 0 less than or equal to x less than or equal to 4. Members, tell me, this is A, this is part B. Which part do you think I'm going to take on when I say that this is my domain? Which part do we consider? Put in the chat and we see. Which part shall we consider? A, B. Aha, very good. So we shall only consider the part of B. So when you look at that part of B that we are considering, you will notice that that part of B, you'll notice that that part of B now that we have restricted, it will start from 0 and it will go like this. And when you draw your horizontal line, you will notice that your horizontal line can only meet at one point. So that is what I'm saying. That's what you call restriction of the domain. So the domain, you remove those x, you restrict the x values where they start from. Members, may I assume that it is very okay? Have you understood what we call restricting the domain? Okay. Okay. Let me ask, I've seen Magez saying he's very confused. Magez, have you just joined? Magez? Virginia? I wanted to know what is confusing such that I can support.
Yeah.
Yes, Virginia, where are you getting the problem?
I've just joined.
Oh, okay. Now I get. Okay, Magez, I think the best is you're going to catch up with the next work we are doing.
Yes, teacher.
Okay, then you will get time and then you review what we have already looked at. Okay, now we go to the next one. Now the next one, now we are going to use, now those first ones I showed you were using the graphical approach. Now we are going to start on what we call the, we are going to look at now what we call the algebraic function. I know in senior one, you looked at what we call the function machines. Now, for each of these machines, or what we are going to be dealing with, you need to know what we call an inverse. Members, when you look at our machine, this is what we call our input, and what we get is what we call our output. So when you read, that is, when you read, you are putting in your efforts. So that is the input. What you get in the papers is your output. It shows how much efforts you put in your revision. Now, I want to tell me, these boxes are the ones that are going to perform the functions. Now, I want you to let me know, when we have x as our function and it enters inside the machine, which output shall we have here? Put your answer in the chat. Yes. Now, world, people are saying 5x, very good. So here we shall have 5x, very good. Now, when the 5x members, you can notice that when x comes in, we shall have 5 times x, which will give us 5x. So that is the output here. Now, when the 5x enters inside members here, what is going to be our output? What is going to be our output? Very good. So Patricia is saying that this is going to be 5x minus 2. And therefore, allow me to conclude that now our function, which we can call f of x, will be 5x minus 2. So that is how our function is being formed. Hope that is very fine to everyone. Now, if this is what our function is, now we are going to ask ourselves, what about when we take the reverse order? The reverse order means, what about when we are going back? Now, when we are going back, we are going to start with x. Now, members, I want you to look at each process. When you look at this process here, this was -2. Now, members, what is the inverse of -2? What is the inverse? What is the reverse? People are saying it is a 2. Very good. So members, a negative, its inverse is a positive. What about members? So here I'll have plus 2. I come back here. Members, here we had a multiplication of 5x. What is the inverse of a multiplication? What is the inverse of a multiplication? I think it is hard to type. What is the inverse? Very good, Patricia. So when you have a multiplication, the inverse is a division. So members, here, we shall have divide by 5. So members, we start now entering our x. Now, when our x enters here, members, what is going to be our output? X has entered. What is our output? Put your answer in the chat. X has entered. What's going to be our output? Here, for the first box. Members are saying 2x. Gloria, not yet, not yet. X plus 2. Remember the operation here was addition. Yes, so it is x plus 2. So members, here we shall have x as our output plus 2, or alternatively, some of you want to write 2 plus x. Now, hope that is okay, members. Now, remember here, the sum or the operation is a plus. So when it enters, you have to add. It's like having 2. 2 when it enters here, 2 plus 2 gives you a 4. That's what we are saying. Now, when the x plus 2 enters here, members, what is going to be our output? What's going to be our output? Very good. Yes, Magez. So here our output is going to be x plus 2, everything divided by 5. And members, now allow me to let you know that our function was 5x minus 2. But if our inverse of f of x is going to be x plus 2 out of 5. So when they give you f of x is equal to 5x minus 2 and they want its inverse, this is its inverse. That's how you obtain it. Members, is that fine? Is it okay? Okay, very good. So let us first write it down. So you break it step by step. So you first take it forward and then you bring it backwards. Okay. So you can first write, and let me hope we are on the same page. Joyce, hope we are on the same page. Okay. Okay. When you finish, you let me know, and then we continue. Okay. Gavanian has finished. Hunt has also finished. Okay. Even Patricia. Okay. Okay. It seems people have finished. Okay. We can go on. Okay. I have another one here. So still we do the same thing. You enter step by step. So the first one, we have x entering into this point here. So members, what shall we have as our output for the first part, for the first output? 5x, very good. So here we shall have 5x. After having 5x, we continue. Megan? Megan, tell us, when we put 5x here, what shall we have as our output? Yes, Megan, are you on? Okay. So members are saying it is going to be 5x minus 2. Then still we continue. to enter. Now that is where, very good. So the last one, we shall have 5x minus 2 divided by 4. So what does it mean? It means that our function f of x that was put into the machine is equal to 5x minus 2 out of 4. Now, what are we going to do? Now we are going to obtain the inverse of the function. Now, how do we obtain the inverse of that function? Shekaina. Shekaina, are you on? Okay. Now, what do we, can someone raise up the hand and then you take us through how we are going to obtain the inverse? Now we are going backwards to obtain. Okay. Yes, Samara.
Yes, good morning, teacher.
Yes, good morning.
What would happen?
Mhm.
Okay. The 4 with the division sign will become a multiplication sign. So it
It's
will
going
be
to become a
times.
multiplication side of 4. Good.
Then the
Then here,
negative 2 will become plus positive 2. It will be positive 2.
plus positive 2. Good.
Yes. Then the times 5 will become divide by 5.
It will become divide by 5.
Yes.
Okay. Then how we start on our output. So when we enter the x here, what's going to be our output here?
4 times x.
Which is
4x.
4x. So when we enter the 4x here, what's going to be our output?
4x plus 2.
4x plus 2. Very good. When we enter the 4x plus 2 here, what's going to be our output?
4x plus 2 divided by 5.
4x plus 2 divided by 5. And members, this is going to be our inverse, f inverse of x. Very good. Hope that is very fine, members. Hope that is very fine to everyone. Is there anyone we have? Okay, it is very fine. Now, do you know what sometimes will happen is that then they may not give you the machines and you may need to draw it yourself to come up with that kind of machine. So what about when they have told us to develop our own? Can everyone be able to develop your own? Imagine they have given you a function and they are telling you that find the inverse of that function. Can we be able to find the inverse of the function? So now that is where I want us to go. Here I have given you the machines. What about when they have not given you the machine? Can you be able to create your own machine? Okay. Okay. Hope members, okay, we are going to start. Now we are going to create. Let me hope members had finished the other screen. But let me first take a bit back. Maybe some are still writing. When you finish, you let me know. Okay, people have finished. Now we go to creating a function. Now, creating a function machine, one thing we need to take note of, one, you must first know that you must have an input and output. Now, let me first ask you to first create the way you think. As long as what you have created at the end, the output will give you 3x plus 5. Can you first try it in your own book? Or you have your input, so our input is x. So you create your machine such that the output you obtain is 3x plus 5. Yes. So that is what I want. First create it and then you'll tell us what you have. Or someone will raise up the hand and then you take us through how you have created your machine. Okay. I'm seeing a hand up. Who has not? Yes, Faith. Faith.
Good morning, teacher.
Yes, good morning.
My machine, the
Mhm.
input is X.
Okay, you have said X.
Then in the next box, there is a times 3.
Time was 3. Okay.
Then plus 5.
Then plus 5. Oh, sorry, plus 5. And what is this? Is plus 5. Okay, so which output did you get?
3x plus 5.
So you got 3x plus 5. Okay, now we go back to get our inverse. Mhm. So here, what did you have?
That is minus 5.
Minus 5
Then that is divide by 3.
divided by 3. Okay, and what is for the first box when you enter this? What was your output here?
X minus 5.
X minus 5, good. When you enter here, what was our output?
X minus 5 divided by 3.
X minus 5 divided by 3. And this is our F inverse of X. Very good. Thank you. That is correct. Okay. Thank you, Flavia. Yes, Gavania. Gavanian. Yes. Gavanian, you can go on. Talk. Oh, I think I'm failing to get Gavanian. Another person who wants to take us through? Okay, yes, Olive.
Good morning.
Yes, good morning. Olive, go on. Oh, I'm also failing to get Olive. Lynette.
Good morning, sir.
Morning.
For my x, at first I have x, then times 6,
Okay, so the second here you had time was 6.
then negative 5,
Then here, negative 5.
then divide by 4.
Then divide by 4. Okay, good. So what was your output for the first entry?
My output was 6x minus 5 divided by 4.
Oh, this is 5. Sorry, I don't know. I wrote 6. 6x minus 5 divided by 4. Okay. Can we come back? Here you had
To the inverse,
hmm,
from backwards I have times 4,
times 4
plus 5
plus 5
divided by 6.
divided by 6. Okay. So what is your output?
4x plus 5 divided by 6.
4x plus 5 divided by 6. And this is our F inverse of x. Okay, thank you. It is correct. Okay, members, let me know. Kisache and Mark have not yet obtained your question very well. Yes, I've not yet. Can you maybe throw more light? Mark, Monique, as also Mark, I've not picked what you meant. Yes, Mark, unmute. And Monique, you can as well unmute.
Teacher,
Mm.
while inversing,
Mm.
why did you start with for the first function?
Mm.
You started with x minus 5. What if someone starts with 5 minus x?
Oh, now, Mark, you first tell me. 5,000 minus 1,000 and 1,000 minus 5,000. For the first one, which answer do you have, Mark?
4,000.
4,000. Then for the second one?
Negative 4,000.
Negative 4,000. Now we come back. You have said x minus 5 and 5 minus x. Are they different? Are they the same?
They are different.
They are different.
Yes.
So have you got the answer to your question?
Yes, teacher, I have realized.
Okay. So always do not forget that this sign always must accompany the number. So if you write x minus 5 or negative 5 plus x, that is very okay, because the negative has still been maintained on 5 as initially. That is the most important one, but not interchanging the negative to put it on x. Okay. I saw Monique, kindly go on.
Good morning.
Good morning.
It's me and my question, please. You repeat for me this step because I have joined. I don't know how you're getting things.
Okay. Monique, I think what we are going to do to be fair, kindly stick on such that you can learn the algebraic one, the other method I'm going to teach. Yeah,
Okay,
but you review the recording such that you can get on the same page.
okay, sir.
Okay. Okay, we continue, members. Now we are going to look at the algebraic approach. Now, we are looking at the algebraic approach. Now, when it comes to this approach, now I've given you the number machine, but now I don't want you to use the number machine. What if you want to just go through the calculation approach, just calculating? Now, in case we want to obtain or to go through the calculation and you want to do it, what do we do? Now, in case this is our number and we want to find the inverse, we shall say that let our F inverse of x. Members, let me hope we are together. I can say that let our F inverse of x equals to y. What does it mean, members? If I let my F inverse of x is equal to y, our function of f of x is equal to 3x minus 2. So what do we do, members? What we do always is very easy, or it is simple. This function I have let here, this one here, where I've said f inverse of x is equal to y, it means that when you try to take the inverse this side, it means that x will equal to f of y. That is the meaning. That x will equal to f of y. What does it mean? It means that where you have your f of x here, you are going to replace it with here where you have your f of x. you are going to replace, you are going, like we said that inverse, it is a matter of you interchanging. Your x becomes the y. So you interchange, where you have x, you put y. Where you have y, you put what? X. Initially, I told that f of x means y. So where there is f of x, we are going to put x. Where there is x, we put y. So I will say 3y minus 2. Members, have you got the interchange I'm making? Where there is x, put y. Where there is y, you put x. Is that fine, members? Let me know through the chat. Are you noticing what we are going to do? Okay, people are saying, yeah, some not yet. Okay, not. Okay, let us first complete. Now, we said, I want to take you back, that when I have f of x is the same, is equal to 3x minus 2. But in function, your f of x represents, is like y, having y, equaling to 3x minus 2. But since we say that inverse means a reflection in the line y is equal to x. So what do? We interchange. Where there is x, put y. Where there is y, put x in your equation. Now, like this equation. So here where you have y, I'm going to put x. Where there is x, I put y. Now, after doing so, I make sure I make y my subject. By making the subject, it means that leave your y on one side. So what am I going to do? I'll say now x is equal to 3y minus 2. But I want to remain with y only. So I'll have these 2 taken over this side. So I'll say x plus 2 is equal to 3y minus 2 plus 2. And therefore I'll have x plus 2 is equal to 3y. Now, when I reach here, it means that I want y. I will divide by 3. I divide by 3. This and this will cancel, and therefore I'll have my y is equal to x plus 2 divided by 3. But initially, I said here that f inverse of x is equal to y. So I'll come and I conclude that f inverse of x is equal to x plus 2 divided by 3. And this is my answer. And when you look at the number we started with, you'll have to see that that is the same answer. So this is when we are using the calculation. Members, let me know through the chat whether you have picked something. Have you picked something? Okay. Yeah. Okay. Okay, yeah. Members are saying they have picked something. Okay. Now allow me to display here such that you can even write the steps. Oh, I take back. Okay, let me take back. You first write, and then I'll display the other one, and we summarize the steps. Okay, Linda, you have a question? Yes, Linda.
Good morning, sir.
Good morning.
Sir, how comes that these two crosses and goes to this side of x and again it remains this side?
No, like what we are doing, Linda, we want to have y on its own side alone. So anything with that is on the same side with y, we remove it and we take it to the other side.
Okay, sir.
Yes, so your aim should always be to have y remain on its own side alone, independently. And once you achieve that, it means you have found the inverse of the function.
Okay, okay, sir. The answer that we have got is like the value of y, something like that. But here we summarize it for us as f inverse of x is equal to 1.
I beg your pardon. Oh, now here where I said x is equal to y, I was showing you that inverse means interchanging your x into y, your y into x. Because inverse is like a reflection. Like when you look yourself into the mirror, what you see is your inverse. So that is what we are trying to say. That where there is y, put x. Where there is x, you put y.
Yes, sir. Thank you.
Okay. Yes, Gabby, you are right. As long as you interchange X and Y and then you solve, that is it. Okay, members, can you summarize these steps? I want you to summarize these steps in your book, how to find the inverse. Okay. Okay. When you finish, you let me know. And feel free to write like in your own words, the different steps. Okay. I think members have finished. Okay. Okay, I think we are finished. Okay, good. Now we continue. Okay, pick something you want to write from here. Just pick. You don't need to write anything. Just pick something you may want. Read through and then pick what you think you want to write. So when you finish, you let me know. Okay, Aina said it's good to go. Lydia said finished. Chemtaya said finished. Okay. Okay. Now we are going to work out this, but don't you think you can first try it on your own? Okay, but we first go through one and then the rest we try. Now the first thing we shall say that let our F inverse of X equals to our Y. Now, what does it mean? But we have said that always our F of X will equal to the Y here. So what does it mean? We have said that F of X is equal to 4 minus 3X. So you are going to swap your F of X here where there is F of X becomes X. Where there is X becomes Y. Like that. Then your task is to make Y the subject, like to have Y be on its own, nothing else. So the first thing you do, you remove the 4. Then I'll bring the 4 this side. So since it is a positive, it will be now X minus 4 equaling to 4 minus 4 minus the 3Y. So here I'll have x minus 4 equaling to negative 3y. But we have said we want y. So I will divide by negative 3, divide by negative 3. So here I'll have x minus 4 out of negative 3 is equal to y. Now here mathematically, you can remove this negative and have it up. So I can have negative into x minus 4 out of 3. So when this negative enters inside members, you end up with negative x. This negative multiplies here. This negative multiplies here. So there you end up with a plus 4 out of 3, which you can write as a mathematician as 4 minus x out of 3. And therefore, your inverse, f inverse of x, will equal to 4 minus x out of 3. Now, those who have mastered the machines, also you can, it is the same thing, whereby this is x. The first thing you do, you choose what you want. You choose what you want. So I can say, I'm going to start with the having, here I have times, this is times negative, okay, times negative 3. Then after that, I add on the 4, like that, like that. It is also okay. Yeah. But now you need to know how you're going to work out with your machine. Okay. So, members, is that fine? I want you to learn the algebraic one because it makes life a bit much easier. Okay. Magazine? Yes, Magazine?
Teacher, I've understood the whole process, but I have not like a problem, but how do you replace function of x with x and then how does function of x turn into x and then why do you just abruptly turn 3x
No,
to
we are
3?
not abruptly. Magazine, remember, we say that inverse means a reflection.
Yes,
In
teacher.
the line, y is equal to x. And we say that when we are reflecting, in case I have 2 and 4, what is going to be our inverse, Magazine?
-2, -4.
Really? Not really. Because we say that when you are reflecting in the line y is equal to x, it's a matter of just interchanging. What has been your x becomes your y. What has been your y becomes your x. So what is going to be our inverse?
4, 2.
Or 2. What if I had -3 and 4? What is going to be your inverse?
4, -3.
For -3. Now, that's what we call a reflection. Like when you look yourself in the mirror or anything, when this is the diagonal line, when maybe there is an object somewhere here, that object will be formed somewhere here. So it is directly the opposite of each other. So what we are doing for interchanging x and y, we are reflecting algebraically. So we are interchanging your y to be the x and then your x to be the y. That's what we are doing. I don't know whether now it's a bit clear.
Yes, teacher. Thank you.
Okay. So that is the background where we are picking it from. Okay. Members, can we try this? Now, the first thing I want you to do, always first find your h inverse of x. So that is the first thing I want you to do. So they have given us h of x equaling to x squared plus 5. So first find what is h inverse of x. That is the first step. So can we first do it on our own? When you get an answer, feel free to share with us in the chat. Okay. Some people are getting. Okay. Magezi, you can take us through. I'm seeing your hand is already up.
I forgot to put it down.
Okay, but you can take us through again. No worries.
So I let my oh, no. So you have h into brackets x. Okay, h function of x is equal to x squared plus 5. Then you replace. Okay, let the inverse of h function of x be y. Yes, and then x is equal to y squared.
X
You
is equal to.
is equal to y squared plus 5. You eliminate the 5 from the other side, so you subtract on the other side. X minus 5 is equal to y squared. So then to eliminate the square, we have to find the square root. So you square it on both sides.
Okay.
Yeah.
So,
Is equal to. So y
okay.
is equal to x minus 5.
Okay, x minus 5. Yes. So then you go to the next thing. You place in your 30. So you say now, my h inverse of 30 will equal to 30 minus 5, which will give us the square root of 25. Then what is your answer? 5. Very good. So here, our answer will be 5. Now, you read the question very well. Here they told the value. Now, when they specifically tell you the value, you write 1. In case it was values, you would have written 5 and negative 5. So please take note of that. Okay, I start with Joshua. Do you have a question, Joshua?
Yeah, at first I was stuck, but now I've known what was wrong.
Oh, okay. Amara?
No, teacher, it's okay. I was also with the same mistake, but now it's okay.
Okay. Linda?
So what if I just take it straight?
What
Fix
if?
the 30. Just take it straight and fix the 30 there at the beginning as my x.
At the beginning, you say?
I fix my 30.
You did what? I didn't get you well.
I fix my 30 there at the beginning. There as until 30 is my x. So I just fix my 30 there at the beginning.
At the beginning.
Yes.
Okay. It can work, but You may miss out some mark, but it's not bad. It can work. It can work, but I would advise that at least show how you are reaching there to the final. But I know I've seen it can really work. But maybe let's try it on other numbers. In case it works, then it is really very good. Okay, it works. It works like a shortcut. Yeah. But it is very fine, Linda, when you fix it just here on this step. Okay, but I would advise to complete such that someone can be able to follow up your work. Otherwise, when you insert it from there, someone may fail to follow your work through. Yes, Trevor.
Okay, I was just asking, what if maybe I extend the square to the h inverse of 30 square, then I work out like that? Would it be wrong?
I beg your pardon, from where? From which step?
Like maybe I don't eliminate the squared from that part of y squared, but I continue with it, then I eliminate it with h inverse of 30 squared, then I eliminate it from that side or from that step. It be wrong.
Like you say h inverse of x, then you put a square root.
Like
No, like you
maybe.
put a square.
Yeah.
Then you say is equal to?
Is equal
X
to
minus 5.
Yes.
No, it is okay as long as you remove the squared very well.
Okay. Thank you.
Okay. Okay. I think we are good to continue. Okay. Allow me now to give you another one. Now, here they can combine them with our composite functions. So now we can do some one that is combined. But let me first give you, what if you find a fraction? Okay, now I have g of x is equal to 2x plus 4 out of 5x plus 3. And now they want us Roman 1 to find h inverse of, this is g. They want us to find g inverse of x. G inverse of x. Can everyone first try it out? Can we first try it out? Hmm. Okay. So here, being able to cross multiply make the subject is very key. Kathy, are we on the same page?
Yes, teacher.
Okay, Kathy, can you take us through the first steps?
Teacher, I'm still doing.
Okay, tell us what you are doing.
Okay, I first let the inverse of x, y.
Okay.
Then I said x is equal to 2y plus 4. Then out of 5y plus 3.
Okay, good. Continue.
Then I want to remain with only y. So I did this.
You
2y.
did what? You cross
What?
multiplied?
Yeah.
Okay.
2y out of 5y
Out of 5y.
plus 4
Plus 4
out of 3
out of 3.
is
Like that?
equal. Yeah.
Is equal to?
Yes, is equal to x plus 4 out of 3.
Oh, okay. As if I picked, as if you did like this. I've written your thing as if you did like this.
Yes.
Yes, something like that.
Yes.
Okay. Now, Kathy, this one will not be mathematically correct because these 5 and 3, they are contributing. All of them are contributing to sharing 2y plus 4. So you cannot separate them like this. So you
Okay.
cannot separate an individual. It's like having 1 plus 3. Let me say you have 1 plus 3 out of maybe 5 plus 2. And then you do 1 out of 5 plus 3 out of 2. This one is not the same as this. So they are totally different.
Okay.
Is that fine?
Yes, teacher.
Now, here, the best step you would have taken is to cross multiply. So you say this is out of 1, then you cross multiply. Is that okay?
Okay.
Now continue.
When I cross multiply x into brackets 5y plus 3 will be equal to 2y plus 4.
Okay, very good.
Now I'll get 5xy plus 3x is equal to 3y plus 4. Sorry, 2y
Okay.
plus 4.
What are you aiming at?
I want to remain with y on one side.
Very good. So can we have all of them on one side and anything without y taking the other?
5xy plus 3x minus 4 is equal to 2y.
Okay. Are you seeing some y still on one side? There is y.
Yes, I see it.
Can we also remove it? Can we remove the whole of this and also take it to join the other y?
Okay. 3x minus 4 is equal to 2y
minus 5xy.
Okay. Now, when you look at 2y minus 5xy, what is common in both? What is here and it's there?
It's y.
Y. So can we factor it out? So when I factor y, what are we going to remain with here?
Pardon?
I have removed the y, not so? Because you have said it's common. So when you remove y, in this position here where you have 2y, what do we remain with?
2.
2. Then what about here?
Negative 5x.
Minus 5x. And this one will equal to 3x minus 4. Very good. Now, how are we going to remain with y? Imagine, Kathy, you have this. 3x is equal to 6. How do you remain with x?
I divide. Both.
So what are we going to do here?
I divide 2 minus 5x on both sides.
Okay. And so what is your y?
Y will be equal to 3x minus 4 out of 2 minus 5x.
Okay, so what is going to be our inverse in conclusion? Okay. Thank you, Kathy. That is correct. Members, do we have the same answer? Do we have the same answer? Joy, I don't know whether, Joy, you have seen your mistake. Joy, have you been able to see the mistake?
Yes, I have.
So that is how we deal with when we have fractions. That's what we do when we have fractions. Yeah. So make sure that you, also when you have those algebraic fraction, you make sure. Now, I know some of you, it depends on the way, you factored it out. So when you find yourself having 4 minus 3x out of 5x minus 2, this is the same thing like 3x minus 4 out of 5x minus, out of what? 2 minus 5x. So they are the same. So in case you have an answer like this or like this, all of them are the same. So it depends on how you worked out. So for you, in case you reached this point here, like here, Kathy brought I think the 4 this side, but some of you took the 3x this side. So when you take the 3 this side, for you to get 4 minus 3x. So it is the same thing. So don't say my answer is different. Okay. That is one. So members, can we now part B? Part B wanted us to find F inverse of, find F inverse of 2. So can we go on and now substitute in? Yeah, have we got some answer? Negative a quarter, negative a quarter. It seems everyone is getting negative a quarter. So I expect you to have 3x minus 4 out of 2 minus 5x, whereby you say 3 times 2 minus 4 out of 2 minus 5 times 2, 6 minus 4 out of 2 minus 10. So this is 2 out of negative 8. So members, you have always reduced your answer. Yeah, so always reduce your answer. You say by 2, 1, by 2, negative 4. So you end up with negative a quarter. So that is very, very fine. Okay, so we can do another one. So that was briefly when you meet such numbers that may require you to go deep. However, here, do not worry. When in case making the subject is not yet fine, there is another topic in senior 4. It's called equations and inequalities. So you'll cover it in first term in your different schools. So it will help you to learn further on how you can make the subjects. So it will help you. But here, this is the ground, foundation. Okay, I have another one. If h of x is equal to 3x minus 2 and g of x is equal to 3x plus 5. Okay, our Roman 1, find h g inverse of x. I want you to take note. It is hg inverse of x. Now, members, that is Roman 1. I want you now, that thing is totally different from hg, x, everything inverse. They are totally different. Here, it is only g whose inverse is needed, then you replace it in h. So the first step, can you first find g inverse of x? That is the first thing I want you to do. Find what is g inverse of x. That is the first thing you have to do. So your side work should be, let me first find g inverse of x. After finding it, that's when we can go on with our composite function. So when you get the answer, you can place it in the chat. Okay, Gavanian, unmute. Yes.
The inverse of this x.
The inverse you are getting?
Yes.
It is?
I've said x is equal to 3x plus 5.
Or first take us through how you have reached there.
The first one. Yes. Now for the side of plus x. I've said x is equal to 3x plus 5.
Oh, okay. Did you first let g of x is equal to y?
Yes.
Then after you said?
Where there is the x, where there is inverse of x.
You put x,
X plus, yes,
is equal to?
3x plus 5.
Remember, we have to replace where there is x, you put y. Did you
Yes,
replace?
I replaced myself.
So you got 3y plus 5, like that?
Yes. Now I said
Continue.
x minus 5
X minus 5
is equal to 3y.
3y, good.
Divide both sides by.
Divide both sides by 3.
Now x minus 5 divided by 3 is equal to 5.
Okay, is equal to y. Therefore, your g inverse of x will equal to
X divided by 3.
Very good. Now, can we go and get now our hg inverse of x? So I think let the whole group take us through. How many are you, Gavania?
5.
Okay. Let's go.
Now where there is the inverse of x, we are going to replace it by x minus 5. X minus 5 divided by 3.
So where there is g inverse, we shall put x minus 5 out of 3. Because we have replaced this. So what shall we have now?
Now we are going to have 3 into brackets.
3 into brackets.
X minus 5 divided
by 3.
Then we close brackets minus 2.
Minus 2, very good.
We are going to have 3x
minus 15.
3x minus 15.
9.
By 3, then minus.
Now, that is, someone was mentioning 9. Now, remember, this 3 only affects what is up, doesn't affect what is where? Down. Alternatively, okay, that is 1, so it will remain 3. Let's continue. Minus
2. Now, we're going to multiply 3 both sides.
But now here, we cannot say we are going to multiply because this side we already have hg inverse of x. Think again.
We are going to have 3x minus 17.
Now, remember this is one bracket, so you cannot combine the negative 15 and the 2. But let me first remind you something. Now, Gavanians, remember imagine you have 4 plus 2 out of 2. What is your answer, final answer?
6 over 2.
6 out of 2. And your final answer is?
3.
Very good. Now, but do you know, you can as well say 4 out of 2 plus 2 out of 2. So what is 4 out of 2?
Is 6 out of
It is 2.
2.
2, plus 2 out of 2.
1.
Which is?
3.
Are you noticing that we get the same answer?
Yes.
Can we apply that knowledge here on this step here?
3x out of 3.
Minus
15.
15
over 3.
Then you have this minus 2. So what do you get here? 3x out of 3 you get?
X minus 5
Then minus
2.
So our answer will become
X minus 7.
minus 7.
Thank you.
Very good. So that is your answer. Alternatively, are you also noticing? Alternatively, at this point here where you had 3 into x minus 5 out of 3, you would have cancelled this 3 and this 3 at a go, such that you remain with x minus 5, then minus 2. Before you bring it inside, are we together on that?
Yes, ma'am.
Okay. Hi, thank you.
Thank you, sir.
Okay.
Bye-bye.
Okay. Now, members, we are going to go to the second part. Hope members we are on the same page. Hope we are on the same page. Are we on the same page? Agava says no. Agava, maybe you can let us know where you are lost such that we can help. Yes, Agava, unmute. Okay, I'm failing to get Agava. Now, our next part, we are going to do still the same number. Allow me to, now the second part you are doing, you are finding Roman 2. You are finding H inverse, G inverse of X. Yes, Favor.
I was just trying to say, Agava put in the chat that his mic is not working.
Oh, okay. Has he put the problem such that we can support?
I don't know. He didn't. He just said it's not working.
Oh, okay. Agaba, maybe you can type in the chat and you let us know where we can support you from. Oh, how the G inverse went in between the 3x minus 2. Okay, now, Agaba, we looked at composite functions, and we say that if you have a function, let me say hg of x, this one means that you have h, then inside h, you put g of x. Now, for this time round, we had h and we had g inverse of x. So this one means that the whole of this one, of g inverse, is going to be put in h. So meaning that you say, but our h, I think, was given by 3x minus 2. So what does it mean? It means that the whole of this, you carry it the way it is. Whenever you see x, you put it there in h. So when you look at our h, we had 3x minus 2. Now this position where there is x is where you're going to put the whole inverse. So meaning that you have 3, then you put the inverse. You put the inverse of g inverse of x, then minus 2. So here where there is x is where you put that inverse you have obtained. Let me hope I have answered your question. Okay. Now for the second part, members, I want you to let you know, here I expect you one, make sure you have your H inverse. Make sure you have your G inverse. You must have both. Such that after getting your G inverse, you get that answer, you put it in H what? H inverse. So I expect you to have two. Oh, okay. Okay, Favor, what was confusing? Maybe you can let us know.
Just like Agava had said, I was confused of how the x minus 5 and all that, how it was coming about, because I joined in a bit late, but I now get it.
Oh, so like you joined the lesson late?
Yeah.
Oh, okay, sorry.
But it's okay. I'm now fine.
Okay. If you are fine, can you first take us through now,
Please.
such that we test whether you are really fine?
As in, I'm fine with what you had just done. I'm just following up.
Okay, but I know you have been attending lessons, Favor. So, Favor, our h of x is equal to 3x minus 2. That is our h of x. Can you get for us the inverse? Favor, is it
Yes.
possible for you to get for us the inverse?
It is, but teacher, I'm not fine. As in, let someone do.
Oh, okay. Okay, now I can know the time you joined in. It is well, Favor. Okay. Patricia has got that. Okay. Joy, you can take us. I saw your answer. Joy,
Yes, teacher.
you take us through how you have obtained your H inverse.
Okay, so we say let H inverse
Mm-hmm.
to x be y.
Okay.
So we say x is equal to 3y minus 2.
Mm.
So we take 2 to the other side, so it's x plus 2 is equal to 3y. Divide both sides by 3, which gives us x plus 2 divided by 3 is equal to y. That's
Therefore,
our H
our
inverse. H inverse is equal.
don't go off, stay on. What was our G inverse? Do we have it already?
Yes, x minus 7.
It is x minus 7. Sure. G inverse. Is it what we had?
Oh wait, no. X minus 5 divided by 3.
Okay. So it was x minus 5 divided by
3.
By 3. Okay. Now take us through now the next steps. Mm-hmm. Okay. Can you take us through the same way we have been approaching composite functions? So we shall say H inverse, sorry. Daniela, we're waiting for you.
Okay, we said G inverse of x plus 2 divided by 3.
Okay, no, okay, I want you to first give us the first step, like replacing your G inverse, which is x minus 5 out of 3. Are you seeing that?
Yes.
Can you now continue? You have your H inverse, not so?
Yes, x plus 2 divided by
X,
3.
so it is x plus 2 out of 3. Now, can you replace where there is x, we put the whole of this?
X
So what
minus
shall we
5
have?
divided by 3 plus
X,
2 minus 5 divided by 3 plus 2 out of 3.
plus 2, everything out of 3. Now, members, I want us to first deal with the denominator. So Joy, I want you to first take us through the numerator, sorry, alone. So what shall we have here?
X minus 5 plus 2 out of 3.
X minus 5 plus
2.
Remember, these are
Yes,
like
plus 2 out of 3. Well, everything out of 3.
What is your LCM? Because now you either cross multiply or you find the LCM of 3 and 1.
LCM is 3.
LCM is 3, okay? Allow me to first remove this. So we shall say that our LCM is 3, okay? After obtaining the LCM.
Okay. X minus 5 divided by 3 times 3 gives us X minus 5.
X minus 5, plus
2 out of 1 times 3, which gives us 6.
Okay, here we shall have 2 times 3. Okay, continue.
X minus 5 plus 6 divided by 3.
Plus 6 divided by 3. Okay, continue.
X plus 1 divided by 3.
Divide by 3. Okay. Now, members, this is what we are going to put in our numerator. So now we shall come back in our numerator and we put x plus 1 out of 3. Everything divided by 3. Joy, let's continue.
Okay, we have X plus 1 divided by 3. Can't we get the reciprocal?
Continue, yes.
X plus 1 divided by 3 times 1 out of 3.
Times 1 out of 3, good.
So that's 1 into brackets X plus 1.
Okay, which is the same as x plus 1.
X plus 1.
Out of?
9.
9. Okay, thank you. So that is our inverse of the two of the composite functions. Now, members, in case you have a question, kindly raise up your hand. Patricia, I think she had already obtained the answer. Magezi check out. Jonah, yes, that is okay. Kathy, that is very okay. Yes. Okay, now let me take on some few hands. Okay, start. Yes, Linda. In case there is a part you have not understood, you let us know. Yes, Linda?
Sir,
Mm.
what am I putting is that
I beg your pardon?
even the D inverse, not it of the H inverse.
I'm not getting you.
The
You are
H
saying?
inverse. The okay, what answer did you get as the H inverse? Because I think
It
I
is
made a
here.
mistake.
It is here. Have you seen it?
Yes, sir.
That's what we got. Okay, Joshua?
Okay, I have two questions. So the first one is, did the equation of x minus 5 over 3, did it come from the G inverse?
The one, which equation? 3x minus?
No, x minus 5 over 3. Did it come from G inverse?
Yes, it came from here. Like here, our Roman 1. But since I didn't want us to repeat, I just carried it.
Okay, then the other question is, are we allowed to simplify them, like simplifying our answers?
Yes, if you can simplify it to the smallest. But I don't know here which answer are you simplifying.
I was just taking an example. If it was x, if your answer was x plus 3 over 9, then that would be x plus
If it was x plus 3 out of 9, yes. Now here you can simplify as x out of 9 plus 3 out of 9, which is x out of 9 plus 1 out of 3. Maybe when you want to write it like that.
No? I was thinking of writing it the same way you wrote this. x plus 1 over 9, but just that it would be having over 3.
Over 3. Oh, no, now, remember now, Joshua, for you what you are talking about is like saying by 3, 1 by 3, 3. So
Yes.
this is not mathematically correct. Are you getting it? So you cannot just cancel those ones at a go. Because here there is an additive function. Are you getting it? It's like having 4 plus 2 out of 2. And then for you, tell us by 2 by 2, 1. Then you say 4 plus 1 is equal to 5. This one is mathematically not right. Are you getting it, Joshua?
Yes, teacher.
So here, if you want to cross, make sure what you do, in case you have like 4 plus 2 out of 2, what you do, you can separate them and say 4 out of 2 plus 2 out of 2. Then you say 4 divided by 2 is 2. Then plus 2 divided by 2 is 1, which is equal to 3. But don't just cancel the way they are. If you want to cancel in that format, then you must ensure that they can go through, when you are canceling, it goes through simultaneously, that by 2, 1. By 2, this is 2, here it goes through once. So that is the only way you can do it, if it can go through simultaneously, such that you get 2 plus 1, which is 3. But not just cancelling out 1. 1 cannot only cancel, unless also when you have a function, a fraction. Are we on the same page?
Yes, teacher.
Okay. Another question, or they are done? Okay.
They are done.
I'm taking on Gavanian.
Excuse me, master.
Yes.
I'm confused where you put this x minus 5 divided by 3 plus 2.
Where?
I'm confused on the edges on that step, second from this.
Now, this step, Gavanian, remember I have said that this is just our numerator. So I was dealing with the numerator alone. This one, the whole of this, is what I wanted to first simplify before I proceed. I don't know you're getting it.
Yes.
So this is just the simplification of the numerator. But this is like my side work. But for you, you can just go straight from here, you come to the next step.
Okay, master.
Okay. Mugisa?
Excuse me, sir.
Hmm.
I'm still confused on that step of x plus x minus x over 3 plus 2 and the whole of it over 3. I'm still confused on how you have substituted the inverses in that step.
Okay, now our H inverse was x plus 2 out of 3, not so?
Yes.
Now, what we are replacing is this x. Where there is this x is where we are going to put G inverse of x. Is that fine? So meaning that in this function, where there is x, you put G inverse of x, then plus the 2 out of 3. So you carry the whole of G inverse, you put it in H where there is x. But our G inverse was this. So that's why we are carrying it as x minus 5 out of 3, the whole of it. Then we add on the 2 that was there, divide by 3.
Okay. Thank you, sir.
Okay. Trevor?
Okay, for me, my issue comes in where we have x plus 1 out of 3, then out of another 3 again, the denominator.
Okay,
This lower part.
We start from here, Trevor. Trevor?
Yes.
Do you know how to deal with this?
Maybe I'm not quite sure, but
okay.
I thought maybe we would get the half.
Half.
Then we maybe divide by.
Divide by?
Can I say? Okay, yeah, 2.
By 2. Very good.
Okay, now I get the mistake. I'd misunderstood it. Thanks.
Oh, okay. Now it is okay. So members, this is what we did. But just because Joy, for her, what she did, she got that reciprocal directly. So you have to get 1 out of 2 divided by 2. Then this becomes 1 out of 2 times 1 out of 2. Then you multiply the numerators, which is 1 out of 2 times 2, which is 4. So for her, we had x plus 1 out of 3. So it's a divide by 3, which will be now x plus 1 out of 3 times 1 out of 3. So that's how we are getting 3 times 3 as a 9. Okay, the last one, Bridget.
Okay, so me, I'm inquiring the part of x plus 1 over 3 times 1 out of 3. Like, if we cross multiply, does the answer still remain correct?
Oh, now here, Bridget, here, this step I've written, since this is a multiplication, it is already like cross multiplying. So you cannot cross multiply. You can only cross multiply when you have a plus or negative, or you have an equal sign.
Okay.
But in case this multiplication, just multiply the numerators directly and then the denominators separately.
Okay, thanks.
Okay. Okay. Let me hope members we are on the same page. Members, are we on the same page? Okay. Okay, I think we're on the same page. Then lastly, Gavanian, as I give some number now that we shall try out in our free time. Yes, Gavanian?
Excuse me, madam.
Yes.
Miss, I just wanted to ask on the previous topic, am I allowed?
Yeah, ask. Previous
The
topic,
other
which one?
for probability.
Oh, wait a minute. Wait a minute at the end of the lesson, eh?
Okay, sir.
Okay. Yes, I want to just give you here. I'm going to just give you 2 numbers that I want you to do in your free time. In your free time, I want you to try out these numbers.
Okay, sir.
So you will test them. Yes, Joshua?
Teacher, I was asking if it's possible for for example, let's say if 3x was a fraction, like x plus 5, how are you able to solve such questions?
I beg your pardon, when it is?
If the 3x was a fraction, for example, let's say a quarter.
When 3x, give me an example. You tell me what, right?
For example, a quarter x plus 5 over 4x minus 7.
Minus?
7.
7. And like we want to simplify it, eh?
No, like solving the question.
Like solving. Like when they have given you this as your f of x, something like that?
Yes.
And they want, what do they want? Like, what do you want us to?
The inverse of fx.
When they want us to find the inverse, eh? Yeah?
Yes, teacher.
Okay, I'm going to give you a hint. So those are the ones that I want you to try out in your free time. Now, these inverses, when you look at the other word problems they gave us, it is more or less like reversing. Take an example. Sometimes you pay fees, and you find that maybe you have paid extra. Now, the reverse process of giving you back the extra amount is what we are doing. But allow me, I will create some word problems that will involve how we can reverse, and maybe I will share with you later on. Yes, so that is like the inverse, whereby you pay in extra something and they have to give you to reverse what you didn't, what you paid in extra. So that one is the more or less like an inverse, giving you back. So, but we shall deal with it. Now, Joshua was asking, what about when they give us like something like this? Still what you do, you interchange, you say, this is going to be my x is equal to a quarter of y plus the 5 out of the 4y minus 7. So what you do now, you cross multiply. So I'll have x into 4y minus 7 equaling to a quarter of y, then plus the 5. Open your bracket, say 4xy minus 7x will equal to a quarter of y plus the 5. Then make sure that all your y's are on one side. So meaning that I'll have 4xy minus the a quarter y will equal to 5 plus the 7x. Now, when you reach here, you will notice that y and y is common. So I can factor it out. So I get y into 4x minus the a quarter. Alternatively, at this step here, where you have 4xy minus 7x is equal to a quarter of y plus 5, you may decide to remove this 4 down here. Now, removing that 4 means you are going to multiply throughout by 4. So say you multiply here by 4, multiply every term by 4 by 4. So this 4 and this one will cancel. So here I remain with 16x of y minus the 7 times 4, that is 28. 7 times 4, which is 28 of x is equal to y plus 5 times 4, which is 20. Then from this point, you collected the like terms. So you say 16xy minus y is equal to 20 plus 2080x. Then you factor out, you say y now will be 16x minus 1 equaling to 20 plus 2080x. Then you divide both sides by 16x minus 1, 16x minus 1. So you can do it in that app. You can approach it like that. Let me hope I'm just giving you a hint on how you can approach. Now, in case you had gone with this one, now here, still this will be 5 plus 7x. Now, for you, when you reach here, you can divide by 4x minus a quarter. But here you can simplify further. So now, in case you are simplifying further, you know that 4x minus a quarter, here your LCM is 4. So here up, you'll get 16x minus 1. So meaning that now your answer is going to be 5 plus 7x out of 16x minus 1 out of 4. But this 4 here, you can take it up here such that you get 4 into 5 plus 7x, everything out of 16x minus 1. So when you open, 4 times 5 is 20, 4 times 7 is 28x out of 16x minus 1. So you get the same answer. So you can approach it in that format. But what is important is knowing how to deal with the fractions. So dealing with fractions, you need to bring in your algebra knowledge. You need to bring in your working with integers knowledge, even with what we call equations that you are going to be covering very soon in senior 4. Hope, was it Bridget or was it Joshua? I don't know that Joshua, you have got a hint. Okay, Joshua, hope you have got a hint on how you are going to approach it. So that is how you can approach in case the number is of that format. Okay, now you are going to, I'm going to answer the rest of the questions, but I want someone who is going to give us a closing prayer such that I end the recording. Okay, Bridget, are you giving us a closing prayer?
Yes.
Okay, give us a closing prayer. I end the recording, then those who have questions you ask. Yes, Bridget.
Okay, let's humble ourselves in prayer. Mighty Father in heaven, we thank you for this day. We thank you for this morning preps we have had. Father, may everything that the teacher has taught us stick into our minds, and above all, let your be done. I've prayed. Amen.
Amen. Thank you so much. Allow me to end this recording.